The third question says, show that the function given by fx equals sin x is increasing in this, decreasing in this, neither increasing nor decreasing in this. Right? That's what the person says. Now, sin x is, you can observe sin x is not a very difficult thing. This is a pretty simple one. Can I do it with the help of simple graph, right? A simple graphical approach would also suffice, but then we'll also use the analytical approach since NCERT people love the analytical approach, right? But let me draw the graph for y is equal to fx sin x. Fx equals to sin x. So this is the function sin x. This is 0, this is pi, this is 2 pi. This here is pi by 2. Okay, this is the peak, this here is 1. Do you observe that the function is continuously increasing from 0 to pi by 2? Then after that the function is decreasing from pi by 2 to pi. Can you observe that? Yes, that's what the person is saying. And since the function is increasing as well as decreasing in this interval 0 to pi, you can say that it is neither increasing nor decreasing in this interval. Right? This is the graphical approach. If you can draw the graph, this is okay. But then no, that's not sufficient from the point of view of NCERT. Let's see. Let's begin with function fx equals sin x, the analytical approach. So we'll have to find the derivative of this. Yes, let's find the derivative. F prime x is equal to cos x. The derivative of sin x is cos x, right? And once you have noted that f prime x, the derivative is equal to cos x, can you identify the sign of cos x in different intervals? Yes, maybe. For the first part A, what do we have? X belongs to 0 comma pi by 2. In this interval, what will the values of cos x look like? So cos, the graph of cos, as you may observe, the graph of cos moves in this manner. This point is pi by 2, this is pi, this here is 1, this is 0, and this will be minus 1, the lowest point. The highest point will be 1. From 0 to pi by 2, you can observe the value decreases from 1 to 0, but it is always positive, right? For x belongs to 0 comma pi by 2, we know that cos x is greater than 0 and less than 1 as well. Cos x lies between 0 to 1, right? That's what we can observe. But is that all? You can actually write it as this, that 0 is less than cos x is less than 1. We are only interested in this part, by the way. We are not interested in less than 1 because greater than 0 suffices, right? So for x belongs to this, 0 is less than cos x is less than 1, or you can say that cos x is greater than 0. Therefore, the derivative of function f prime x, the derivative function, that is f prime x, is greater than 0. So what can you comment about fx? Since f prime x is greater than 0 in this interval, for x belongs to 0 comma pi by 2 in this interval, therefore you can say that fx is increasing for x belongs to 0 comma pi by 2. And this is what we started with wanting to prove, right? We had to prove, show that the function is increasing in this interval, and yes, that's what we have proved over here. Is that okay? Yes, this is something which you have done. Now let's talk about the second part after that, part B. Part B says that the function is decreasing in pi by 2 comma pi. How will we handle that? Let's take a look at this one, the second part. So for the second part, once again, let's see that the function fx is sin x, and so the derivative of this function will be simply cos x. Okay, and what about the values of cos x in this interval? Part B, for x belongs to pi by 2 comma pi, you can see the graph of cos x. The graph of cos x is this, right? From pi by 2 to pi, the values will be from 0 to minus 1, right? So this gives me cos x is less than 0, greater than minus 1, or you can say that f prime x, cos x, that is f prime x, is less than 0. And since f prime x is less than 0, this tells me that fx is, what do you call this? fx is decreasing in x belongs to, or you can say for x belongs to pi by 2 comma pi. fx is decreasing for pi by 2 comma pi. That's what we wanted to prove, right? That's the complete proof of this one. The second part, For the third part, once again, for the third part, what do we need? We need the sign of the derivative, right? So for x belongs to 0 comma pi, we know that cos x belongs to minus 1 comma 1. This is what we are aware of, right? This is what we know. Cos x belongs to minus 1 comma 1. Okay, since cos x belongs to minus 1 comma 1, so we can comment about the derivative, that the derivative will also belong from minus 1 to 1, right? This tells me that f prime x belongs to minus 1 comma 1. Okay, and can you observe that the derivative is negative as well as positive for this interval, right? Implies f prime x is greater than 0 or less than 0 for different values in this interval for x belongs to 0 comma pi, and on the basis of this you can say that the function fx is neither increasing nor decreasing in this interval. That is what you can comment, right? That's a proof of this third part as well. That's a complete solution of this question, as you can see.